Hi everyone, my name is Chen Xiang and my channel number is 29819. Today, I want to present the individual assignment 1 of regression modeling. First of all, historical origin of the term regression. The term regression was first coined by Francis Galton in his 1886 paper, Regression toward Mediocrity in Hereditary Structure. Galton observes that while tall parents tend to have tall children and short parents have short children, the children's heights tend to move or regress toward the average height of the population. This statistical phenomenon later became the foundation of regress analysis, a widely used statistical method for modeling relationships between variables. Next, statistical versus deterministic relationships. Deterministic relationship is exact and predictable, while statistical relationships involve randomness and variability, rather than assuming perfect predictability. Statistical relationships are often studied using regression analysis, which help measure how strongly variables are connected and predict outcome. For example of deterministic relationship, the area of a cycle is a way A is equal to pi r squared given the radius r. If you know r, you can precisely calculate A with no uncertainty. For example of statistical relationship, height and weight are statistically related. Taller people tend to weigh more, but exceptions exist, like someone being tall but very lean, or short but stocky. Next. Regression versus causation. Regression shows an association between variables. It helps us understand pattern or relationship, while causation means that one variable direct cause another to change. Just because two variables move together does not mean one causes the other. For example, a regression might show that ice cream sales correlate with running that, but the true cause is hot weather, a confounding variable. Thus, predicting causation require control, experiments, and or additional analysis, like randomized trial, to rule out other explanations. Regression alone can only suggest potential causal link. In summary, correlation does not imply causation. Regression versus correlation. Correlation measures the strength and direction of a linear relationship between two variables from -1 to +1, but does not imply any dependency. For example, if studying time and exam score have a high positive correlation, it means that as study time increases, score tend to increase, but it doesn't mean one directly causes the other. Regression goes further by quantifying how one variable affects another, allowing prediction and estimation. It treats one variable as dependent and the other as independent. For example, a regression model might estimate that for every extra hour of studying, an exam score increased by 5 points, giving an actionable insight. Lastly, simple and multiple linear regression model. In simple linear regression, we use one independent variable to predict a dependent variable. For example, predicting house price only based on square footage, the equation looks like y equal to a plus bx, where y is the outcome, x is the predictor, a is the intercept, and b is the slope. In multiple linear regression, we use multiple independent variables to improve prediction accuracy. For example, predicting house price using square footage, number of bedrooms, and neighborhood. The equation expands to y equal to a plus b1x1 plus b2x2 plus until plus bn xn. That's all from me. Thank you.